So, Dr. Francis, the floor is yours. Thank you, sir.
All right. Good evening, ladies and gentlemen, and Happy New Year.
Happy New Year.
All right. I hope you can all see my slides, right?
Yes.
My slides is showing, my screen is showing, right?
Yes, your slide.
All right, that's fine. All right. Okay, so my name is Francis Okoye, and I've basically been, so let me just a brief background about me. So my background is in accounting and statistics, and I've been teaching roughly about 10 years. So I've been teaching in the business school for about 4 years, the University of Benin about 6 years, okay? And over the years, I've been dealing with Excel, then most recently Power BI, SQL, Python, R, so all the quant stuff. So that's what I do. And again, I'm also the faculty advisor for Data Analytics Club at the Lagos Business School. Okay, and today what we are going to be looking at is predictive analytics. Okay, but here more specifically is how do we integrate Python with Power BI. And by training, I'm an accountant. Okay, so you might be asking, so how is an accountant coming into learning Python and all these things? So I think we will discuss all that as we go on. Okay, so basically what we are going to look at, we'll just start understanding from analytics, the various types of analytics, understand the analytics pipeline, then how do we integrate Python with Power BI. Okay, I always like starting with this, okay? Now with technology, we know that data is being generated almost every second, okay? So now if you are saying that you are making a decision, it must be backed by data. That's why they tell you that with the available information now, ignorance is a choice, okay? So that's why everybody will say now that in God we trust, every other person should bring data, okay? And when we try to understand this, then we now see the field of data science now coming in, because everything now is about what? Data. So for you to come into data science, understand that I'm making decisions based on what data that is available, okay? Available what data. So that study of the data, okay? So before we're calling it statisticians, econometrics, data mining, but now we have now moved, we now call data science, and you have different names. But we are not going into the argument between what are all these fields all about, okay? Because I was from the academia, so to me, what I was doing before is data analysis. Now they are calling data analytics. I'm not like, what's that difference? If you keep going into what did this thing, you will never make progress. Just understand at the end of the day, you are trying to analyze what the data. But there are key things you must understand before you go into all these things. The first thing that you must understand is your domain knowledge. Irrespective of your field, whether you are in HR, you are in accounting, you are in sales, you must first of all have a domain knowledge. Okay? So that's the first thing. Then the next thing you need to do is getting that data, because that study of that data is the branch of mathematics which we call statistics. So you must have an idea about what maths and statistics, okay? Then we must now integrate it, because we must now look for a way to make all our what we have as theory become more practical. So that's where your programming skills now come in. So you must have some idea about programming and some particular software, that is the IT aspect. Okay, so this is just an overview of what you need to understand about data science. But as a subset of it, you must understand the whole methodology. Okay, so this is called the CRISP-DM methodology. Okay, now this methodology is just first of all understanding the whole pipeline, how it works. So it's first of all understanding the problem. Okay, once you understand the problem you are trying to solve, the next is that understand what data am I going to use, because remember that your decision is based on what the data you are taking the decision on. Okay, so you make decision based on what the data. So understand the problem, get the data, but you realize that most of the data you extract, I can guarantee that 80% of a data analyst or data scientist, they spend that time cleaning and preparing that data. So you must first of all prepare that, because most of the data do not come in a very clean form, ready for analysis. Okay, so you spend time cleaning what the data. The next thing you need to do is what? Explore the data, which is they call EDA. exploratory data analysis. Okay, you clean the data, you visualize the data. Okay, just understand what the data is about. So EDA. Then you now need to validate, because based on your analysis, you need to confirm, is it trying to address my problem? Okay, then you do your visualization and final word presentation. So this is just how you need to understand how the whole thing works. So it's about understanding, oh, I have a problem in the organization, but for me to solve this problem, I need to get the data. Okay, it is based on this solution that you formulate your strategies to try to solve that problem. Then there are different platforms that come, and one of them is your Power BI, which you can now use to analyze data, to process data, to get those insights. Okay, so if we look at it from a broad sense, when you talk about your data analytics, we'll talk about 4 types. Okay, basically your descriptive analytics, what has happened in the past. Okay, diagnostic analytics, why has it happened? Okay, predictive analytics, what will likely happen in the future? And prescriptive analytics, what are those things we should do to make it happen? Okay, so these are the various types of data analytics. And at each point in our career, we do one of these things. Okay, but maybe we may not call it that technical name, but it's basically what we still do. Okay, now I know most of us have started with Excel. Okay, and we know that Power BI came from also Excel. Okay, so as we start moving gradually in terms of, especially for data visualization, because most of the things you do in Power BI you can actually do in Excel, but in Power BI it now makes life a little bit more easier for you to do your dashboards and presentations. Okay, but you now see that Excel, Power BI, they also have their own limitations in terms of going advanced in your analytics. So that's why you gradually start seeing people trying to integrate your R and Python. So to give your analysis, to make it more robust, because there are some things you cannot actually do, okay, in your Python. So you now need other tools to now come in. So that's where your R and Python now comes in. So basically, when you are integrating your Python with Power BI, okay, there are basic things you can do with your Python in Power BI. So one of the basic ones we can do is visualization. Yes, we know that Power BI is a visualization tool, okay? But Python also, you see people also doing data visualization, but you can't compare puppy with a baby elephant now in terms of visualization, right? So yes, Power BI has its own in terms of how elegant the visuals are, but there are some technical visuals that you may not have in Power BI. So if you are in that space, then you now need to bring in some custom visuals. Okay, some have already been done in the marketplace, but otherwise, if you need it in terms of core statistics like your pair plot, pairwise plot, you may not have that in Power BI. So that's where your Python now comes in terms of visualization. Okay, then in terms of data cleaning and transformation, so if you remember from the pipeline, when we get the data, we need to transform and clean that data. Now Power BI has already, so embedded in your Power BI is your Power Query, which helps you to clean your data, transform the data, and make sense out of it, okay, for you to start analyzing. Yes, there are some things that are actually easier in Power Query to do, but where the cleaning now becomes much more technical, yes, you can use M, okay, if you can understand the M language, yes, you can still do that, but again, you can also bring in Python to also clean and transform your data, and also generate new data for you. And then you can do some advanced analytics. Okay, so advanced analytics such as you are doing your prediction. So for example, in your Power BI, you can do your forecasts. But the problem is that even when you forecast in your Power BI, it only shows you the visual. But what about the data behind it? So they don't show you those things in your Power BI, but with your Python or your R, but for now we are focusing on Python. So with Python, you can also bring in those data, and we are going to see how that works. Okay. So if you are coming into data analytics, so this is the mindset you should have. First of all, I need to learn how do I extract my data, because first of all, there's a business problem you're trying to address. Okay, but to answer those questions, you need data. So I need to first of all learn how to extract my data, irrespective of the source where that data is. And in most organizations, the data are may be in a database. Okay. So one key skill you have to learn is SQL. How do I extract that data? So I can extract that data, but it can also be in Excel, but most of I'm sure the data is already in Excel, so we can also extract it in Excel, take it straight. But otherwise, in most organizations, if you tell, oh, our sales is going down, why has sales been going down? Then you need to ask IT, IT, please give us data. But what IT is going to do for you actually is to query the data for you. But once they have given you the link or IP or whatever, you can connect straight while you are in Power BI straight to the database and bring it in. So that's about extraction of data. And you can also use Python, and I'll show you how to do that. Now, when the data comes in, remember that most of the time the data is never clean. Okay, so you must clean and transform what the data ready. So either you clean with Power Query, or we are going to use what Python, so you can clean it there. Okay, then lastly you can do some what visualizations. Okay, so basically what we are going to show today, I'm not going to dwell basically on the visuals itself. Okay, I'm going to be basing mostly on how do you work with Python in Power BI, so not necessarily the visuals in itself. But before you work with Python in a Power BI, make sure first of all you have installed your Python. Okay, then you have your Power BI. Now, if you come to your set options, you are going to see where you have Python scripting. By default, it may already be set to you for Anaconda. Anaconda is your IDE, okay? But you have to switch it and tell it that I want it to locate my Python. So you have to switch it to this Python here. That is the only time you can connect it. By default, it may be have connected at your Anaconda, but you have to switch it to what? Python 3.8 or whatever version you are using, then click OK. Then that is the only time that is going to work. Otherwise, you are going to be having errors all through. Okay, so let me see if I can share my let me share my Power BI. Is my Power BI up?
Not yet. Not yet.
Not yet.
It's not yet up.
It's not up yet.
Okay. Power BI. Is it up now?
I think it's yes.
Yes, it is.
Okay, it's up now. Okay, that's good. That's good. So, the first thing that you must do is that you must ensure that first of all your Python is already what connected. Okay, your Python is connected. Now, some may ask, okay, I'm not going into core data science, so must I learn Python? Well, Python in itself, remember, it's also a tool, but it's just also a way to make life easy for you. It's just like in Excel, you can do almost everything you want in your Excel, isn't it? But sometimes you see there are limitations with your Excel, then you now need VBA to come in. So that's the same way we can also bring in Python to also help us do some things. Now, if you are using your normal Excel, we would have used get data Excel, okay? But now we are going to use Python to bring in the data. Okay, we're going to use Python to bring in the data. So what you do here, you come to your get data, more. Okay, more. Now, once it comes up, once that comes up, you are going to see where you have your orders. Then you see your Python script. So once you see Python script, then you say connect. But remember, this can only work if you have already set up under your options. You must ensure that you have already set it up here. Where you have your Python script, it must be specific that this is Python 3.8. Because if it's left on Anaconda, it wouldn't work. Okay, so you must connect it at that point. So get data, more. So once that comes up, order, then you see your Python scripting, then okay. So let's connect. Okay, now you see a blank script here. So the way you work with your Python normally, okay, there are basically libraries that you need to work with in Python. Just like in your Excel, instead of you adding up 1 + 1 + 2 + 3 + 4, there's a function already, isn't it? You use equal to sum. So that is the same way in Python. You also have libraries, just like your functions, okay? So in Python, we have what they call some libraries. So we have to bring in those libraries, we have to import them. So we have what they call pandas. So import pandas as PD, okay? Now this is like your Excel. So the way you work with your Excel, this is like your pandas to basically work with your data. And that important library that you need is your NumPy. Import NumPy, so it means numerical Python, as NP, okay? So these are basic libraries that you need. But what we want to do, we want to bring in the data, okay? So I can call it data equal to pd.read, because it's going to be a CSV file. If it's an Excel file, I'll specify as an Excel file. But let me just call in let me bring out my the path where the file is, okay? Let me copy where the path is and bring it here. So you must specify the path, the location. So mine is on my desktop. So employee attrition data, okay? So it's on the desktop. So I need to read it. Okay, so this is how you'd have typed it in your normal Python. So what we are doing in our normal Python, this is what we are trying to do here. Then we click OK. So once that works, you see it has connected. Okay, so just the way you bring in your Excel, you click your get data in Excel. So the same way we are brought in the data with Python. Okay, then remember, most time we are trying to clean the data or transform the data. So you don't just click load, you just click transform what? Data. Okay, so now we are in our Power Query screen. Now, most of the transformation and cleaning you want to do is usually with what? Your Power Query. So, but at this point, I just want to show you how you use the Python in it. Yes, some people will argue that yes, this is easy, maybe easier in Power Query, but I'm just showing you an alternative way of also doing it in Python. And you may see some ways that it's even easier in Python than in using Power Query. Okay. Now, if you are transforming your data, so normally you'd have come here to transform. Then you see your run Python scripts. Run Python scripts. Okay. But one thing you must understand is that anytime you import your data, it always creates a data for you called data sets by default. Remember, I brought in data as data, but we create it as what? Data set. So at every point, it's holding it as what? Data set. Okay. So just to show you a simple way. So for example, if I look at this, my data, I want to create maybe, okay, let's just say age.
Dr. Francis, I think
yes,
we are not seeing the Power Query side.
Oh, the Power Query. Okay, yeah, because it shares. Once it shares, it takes another screen. Is it up?
Yes, it's up now.
Okay, that's fine. All right. So once you have imported your data, so the next thing you just click is your transform. Okay, so when you click transform, you can see your run Python scripts. Okay, so that's where I have Python. So you click on run Python scripts. So remember, because it has already been connected to my Python, so whatever I'm doing in my normal Jupyter notebook is the same thing I'm going to be doing here. But the only difference is that once there's any error, you're on your own. You have to now start tracing where that error is now coming from. So sometimes it's advisable, run it first of all in your Jupyter notebook to first of all see that there are no errors before you copy it and paste it, then run the scripts. Okay, so let's just show a simple way. So for example, if I want to create a new, so in your Power Query, I want to create a new variable. So let's say age, but I want to divide the age by 2. So let me just show how you can easily do that in your Power Query. Okay, so you have here, remember that the whole data is stored in your data set. Okay, now because it's in your data set, so anytime you are working with it, you must first of all call data sets. What is the name of the variable I'm working with? So let me call it, let's say, age 2. So age 2 is just a new variable I want to create. Okay, equal to, now what do I want to do? I want to just divide that column by 2. So remember how your this thing works in Power Query. So age, I want to divide the age, age by 2. So remember how you do it, divided by 2, and that's all. Okay, so if I click OK, if this works, that means it should start creating a column for me. So how do I know it has worked? So it has shown me that it's in a table. So if I click on this table to expand it, remember I created a new column called age 2. So how do I know it's there? So if I check my last column, I should see age 2. Okay, I'm sure this you would have used either M or something to do that, but here you can use Python to also create your column right inside Power Query. Okay, now some other simple things you can also do. So for example, like this particular data set is just trying to understand employee churn-outs, okay, the rate at which employees are leaving the organization, whether the turnover is high or not. So that's the problem they are seeing. Okay, so what you are seeing, so when you talk about the attrition, so yes, have they left? No. So when you are trying to do some form of prediction, everything must be numerical. Okay, so most times in Power BI, yes, we can visualize this data, but when you are trying to analyze it, you need to convert them to numbers. So most time we need to now transform these strings to become what? Numerical. So these are qualitative variables. You need to now make them what? Quantitative. So if the employee has left, we assign 1, yes, or 0 for no. Okay, so I can also do this by creating, so normally if you're in this thing, you can just do your find and replace here, replace values. Okay, 1, where you find yes, put 1, where you find no, put 0 there. Okay, but I want to show you alternatively how you can also do that with Python. Anyway, because it's in Python, there are different ways of doing the same thing. Okay, so one way you can do it, you can use what they call mapping. Okay, so let me just call it so remember it's data sets. That's where the whole table is. So let me call it let me say attrition, let me say turnover, let's say employee turnover. Okay, equal to, so what do I want to do? So data set dot, so what's the name of the column? Attrition. Okay, attrition dot map. So what am I trying to map? So either I can use map or I can use replace. Okay, so either of them. So I'm mapping it. So anywhere I see my yes, I'll put 1, isn't it? So what I'll do, anywhere I see yes, what do I want there? I want to see 1, so I have to put a column there, 1. Otherwise, where I see no, what should I put there? I want to see 0 there. Okay, so let's hope that the enemies are not at work. Then click OK. Then it has replaced it there. So that means I've created another column. Otherwise, I would have replaced it inside that particular table. So this is the same attrition, yes, no, but this is now employee turnover. So if you want to check whether it has worked, then what we can simply do there is just to, let me see, let me bring it closer to it. So or I've used move. Okay, oh, the table is quite large, so the table is quite large, so let me see how to move this. Move to beginning. So this is my attrition here. So can you see where I have yes, 1, no, 0? So just to check whether it has worked, because most time if you leave it, You know, it's garbage in, garbage out. Okay, so it's just to confirm what you are doing, whether it is what right or not. Another thing again you can do. So for example, let's look at this. Okay, let's look at departments. Let's look at these departments. So you have, for example, you have human resource, research and development, sales department. So basically there are 3 departments. But you think that maybe most people who may leave, they are in sales departments or they are in research department. So I'm only interested in sales units. Okay. So what you want to do is that anywhere I see sales, I want 1 because I'm interested in only sales. Every other department will be 0. I'm not interested in it. Only sales departments. Okay. If you are doing this with Power Query, you would have come to conditional column. Okay. Custom column, you can just call it sales department, where the department contains sales. You put it there, give me 1, else 0. That's one way of doing it. But assuming you had a whole lot of departments, so this is where Power Query can make life a little bit easier for you. Python can make life a little bit easier for you. So I can, let me create another, but here you have to create a function though. So if, for example, I can define a particular function, let's say department, let's say X. Then if X is equal to sales, so anywhere I see sales, and one thing you must understand that Python is extremely case sensitive. So the moment you have made a mistake in the names, then you may have an error there, okay? What do I want? Return 1. Else, what should I do? Return 0. So this is what I need to do. So what I want to pick here, I want to now apply it. So if in Python, whatever there's different ways of doing the same thing, okay? But it just show you that what I am doing in Python, I can also run it right inside what my Power BI. So I can call under data sets. Let me call it sales department so that we'll know that it's different. Equal to data sets. What's the name of the department? The name of the column is department. Okay, what do I want to do? I want to apply it to my function. What's my function? Department. So let me confirm. So that's my function, department, and I click OK. So let's. Okay, so I think that has also, but this is just a way to show you that you can actually also do your data, all those cleaning you are doing with your Power BI, your Power Query, you can also do them with Python, all those transformations you are doing. Okay, you can also do them here. Okay, so if I check now, I can see sales departments. Okay, I see sales what? Departments. All right, so these are different ways of doing the basic transformation. Now, if I now ask, okay, if I want to find out relationship, how the data they are correlated with your normal Power BI, even your Power Query, you cannot show that kind of data. Okay, but with just a simple line of code, I can have correlate my data sets and click OK. So what's, oh, data sets. Okay, I made a mistake in the name. Data sets S1S. So whenever you have an error, it is your understanding of how you know your Python scripts that will, that's how you know where the error is, so you can easily trace it. But if it was in your Jupyter notebook, at least you'd have known what to do there. So this is the correlation matrix. So the way you have your normal correlation matrix, I can run it right inside my Power Query. This you cannot do normally. So can you see your normal correlation matrix with your full data? You can't do this normally with your normal Power Query. Okay, but let me show you something else. So let me go back to my Power BI. So let me go back to Power BI to show us. So share screen. Is my Power BI screen sharing now?
It was before, but it's gone.
Oh, okay. So let's see. Okay, maybe because I'm applying changes. So is it showing now?
Not yet. Though. Do you want to share it?
Okay, so let me reshare it again. Is it showing now?
Yes, it is.
Okay, so you have seen that just close and apply, your normal close and apply, and the whole data set has come in here. Okay, so what we are trying to look at is basically how do I know? So if I look at my data, I'm looking for attrition. Do I have attrition here? Let's see, attrition. Did I change the name? So let me see. Okay, do I have employee turnover here? Okay, this is your employee turnover here. Okay, so let me do so. Now, if you see the data set now, otherwise, what I would have done was to simply get it from my Power Query. I would have just changed the data type. So that's why it's not seeing the data type here. Okay, but don't worry, that's not a problem. But the point here is that if you look at my full data set, let me see my data. Okay, this data set that is bringing for me here is my correlation. So I think that's why it's not seeing it. So let me go back to my Power Query. So this is my correlation, my data set from my. So let me bring back my data and close and apply. So that was my correlation data. That's why it's not showing me the full data. But you can actually bring it. And again, you can also plot your heat map using that your correlation data. Okay. I think in the store, if you are looking for your normal heat map, you'll find it there. Okay, so that's fine. I think that's come here now. Okay, I think that's come here now. So look at your attrition, right? This is the attrition data. Attrition, yes, no. Okay, so let's do a count. So let's do a simple count. Now you see, we had a total of 1,400 employees. From the 1,400 employees, 237 have left the organization. Okay, so the question now is that we are saying, this turnover is quite high. So maybe that's in the mind to somebody it's okay, okay? But the question is that we have prevented an employee from leaving if we have predicted that he's likely to leave. Okay, so here you can do a simple donut chart here. Okay, so this is just to show you. Okay, now so this is about what 16%. Okay, in your Power BI, you also have a predictive analytic tool, but in the sense that it can tell you what are the factors that are likely to explain why an employee is leaving. Okay, so there's a visual called your key influencer. If you see your key influencer here, if you click on your key influencer, so key influencer is like what is driving it. So for example, what I'm interested in is what is driving employee turnover. What is driving what employee turnover? So which data do I want to explain? Attrition. Okay. Explained by what? So you can put whatever drivers you think. It can be explained by department, by education, by what again? Let's say gender. So I can just put some of the factors you think that may likely explain them. Okay. Okay, so what explains it to be, sorry. Oh, I clicked on, sorry. Okay, that's fine. So what explains, so you just drag your, so let's do that again. So your key influencer. So your key influencer, so these are the various factors that can drive attrition. So these factors will make it no. So I want to change it. What factors will make it attrition to be what? Yes. Okay, so as many factors as you put in, it will try to see how it can explain. So you can put performance, whatever drivers you think that is driving our attrition. So that's why I say that for you to do this, the first thing you need is your domain knowledge. So it is only a HR person that will know whether these things make sense or not. Okay, but here what is just simply telling you that what is the major driver. If the person is a sales representative, his role is a sales representative, he's 2.7 times likely to leave. Okay, if his job level is 1 or less, maybe over time he has spent only 1 year, he's 2.6 times likely to leave. Okay, if his marital status is single, he's 2.1 times likely to also leave. So it's already giving you the factors that will tell you whether that employees are likely to leave or not. Okay, but the problem here is that can I now pick? So what you would have done here, if you have identified these several factors, then you now have to go and start doing some query to now group the data. But the problem now is that can I now point from the employees that have left, can I predict based on my model if it would have predicted them correctly to have left? And there are some who have stayed and are also likely to leave. Can I identify them? You see, with that, there's no way Power BI can do that for you. No way. Okay, no way it can do that for you. So that is where you now have to bring in more advanced analytical tool like your Python or R. Okay, maybe some other time we may show how to do it with R, but now we're going to show how to do it with Python. Okay, now I will go back to my data. Let's go back to Power Query. So let me go back to Power Query. I don't know if my Power Query screen is showing. Is my Power Query screen?
No, it's not.
Oh, it's not. Okay. So let's see. Power Query. Where's my Power Query? Is my Power Query screen up now?
Yes.
It's up, right?
It's up now.
Okay, that's good. Okay, now what we are trying to do, we are trying to build a model, okay, that can predict if an employee is likely to leave or not. Okay, so remember, I start from the problem, you get the data, clean and transform the data. The next thing we now need to do is to build the model. So that's the stage we are in now. Okay, so up to this point, we are going to assume that we already know the data set, we know the factors. Okay, but this is just for illustration purpose. Otherwise, we would have gone to do a deeper analysis to find out the key drivers. Okay, so let's say for sake of argument, these are the drivers we have identified. So there are some variables here that naturally will not make any sense when analyzing. So for example, most times we cannot just analyze data by marital status. We have to now convert them to numeric data. So if you're interested in single, you can put 1, otherwise 0. If it's an executive, we're interested in one particular one, then we can just replace them with numbers. Okay, otherwise we need to convert all our data to numeric. All our data should be numeric data. Okay, we need to convert all of them to numeric data. And again, so for example, like this is my attrition. I'm supposed to have changed it to 1 and 0, but that's what I have used as employee turnover. So in place of attrition, I'm going to use employee turnover. So that is my major driver, employee turnover. Now, when you are trying to build a model, there are different algorithms that you are going to apply. So the problem is that to know the right algorithm to use depends on the condition. So this is where your machine learning now comes in. So in machine learning, there are basically 2 parts. You have what they call supervised learning and unsupervised learning. So when you say supervised means it's just like a child. It's just like a child. If a child has never tasted maybe sweets, you give him sweets. When he tastes the sweet, you know that this is actually nice. If you give him sweet again, he will accept it because he knows it's nice. Okay? Then you can say sweet is good. Then if you give him something like bitter cola, and you give the child bitter cola for the first time, or lime for the first time, you will see the child's reaction. So by default, the child will already know, anytime I see sweet, it is good. Anytime I see lime, I will not go for it, it's bad. That is how the computer also trains. But how does it train? It trains with what? Data. Okay, so there are basically two. We can break them into three, but for simplicity, we break them into two: supervised and unsupervised. So when you say supervised simply means I will give it a label. This is good, this is bad. So it's like you giving a child sweet. Sweet is good, lime is bad. So you have already told the child this is what it is, good and bad. Just imagine, just like our, I like using this example, like our Nigerian police. Okay. They also do native machine learning. Okay, for example, they see a boy coming with a Benz, he has tattoo, with dreadlocks, earring. Automatically, once they see him, they say based on their data and based on people they have been arrested, he's more likely to be what? A Yahoo boy. So they arrest Yahoo, not Yahoo. So that is native analytics, what they are still doing. In the same way with that, what they call supervised learning, there's a label. Okay, but unsupervised means there's no label whether it's good or bad. It's just based on certain characteristics. Okay, you now select them. Again, it's what our police also does. For example, they see guys drinking at a bar. They come in and arrest everybody. They don't care who is who. When they take them to the station, they start selecting them. These ones with tattoo, dreadlocks, stay one side. Girls, stay one side. Boys that maybe just came with their friends, some pastors by chance were there, stay one side. So what you are doing, you have grouped them. What is called clustering. Okay, that is unsupervised learning. Okay, so with that, you now have to understand it is the problem that you are trying to address that will determine the algorithm you are going to use. Okay. But the heart of all the algorithms we use your regression analysis, what you call your linear regression. So once I'm trying to predict, maybe for example, prices, okay, with numbers, yes, that is what they call a linear regression model. I'm trying to predict stock price, that's linear regression. I'm trying to predict rents in particular area, that is regression. But once it is labeled yes or no, good or bad, okay, then that is what they call binary. So it means that your normal regression that would have taken any number, the numbers are now restricted between 1 and 0. So it now moves to a probability that is likely to be this or not. Okay, so most time we call it binary logistic regression. So that is another common one. Then you have other algorithms like gradient boost, but the question is that, okay, which algorithm do I use? There's a theorem called the free lunch theorem, okay, which says that there's no one particular theorem that will solve one particular algorithm that will solve everything, okay, but you look at, based on the certain criteria, you can say, okay, this may likely work for it, then select different algorithms, then choose which one has the highest accuracy. So that's just a brief overview of algorithms of how it works. Okay, so in this case we are going to just select some certain variables. We may not pick all of them, but you must understand that you cannot just use all variables as they are. You must ensure that they are all in quantitative. For example, business travel, I cannot just use it like this. I have to convert them to numbers. Departments, I have to convert them to numbers, okay, by assigning numbers to them. Okay, so sometimes we call it label encoding. So you can also do that in your Power Query, in your right here, but I'm not going to bother you guys with that. So let me go straight to the algorithm so we can see how it works. So I'm just trying to check which of the, so let me just pick out some, so I come back to my Python, okay, transform. Now the first thing I need to do is that I need to understand what is my y and what is my x. Because in your normal regression, you have y as a function of what? X. Your y is your target variable. What am I interested in? I'm interested in employee what? Attrition. Okay. So I'm going to what? Create a column out of it. I'm going to create a column out of it. So my y is equal to, remember, it's in my data set. So I'll call it what? Attrition. Okay, because I have converted it, I can't just use this attrition. Then I'll use what they call what? Employee turnover. Employee turnover. Otherwise, I would have just converted them 1 and 0. Okay, so employee turnover. Then my x, I'm going to select certain what? Certain what? Explanatory variables. What you call features. So when you hear feature selection, it means I'm picking which variables are likely to explain my turnover. Okay, so let me just pick out some of the data set so I don't waste time on this. Let me just pick out some of the data sets. So I will just pick maybe like age, distance, rate. So you can just select some of them. Okay, you can just select some of them. Okay, so I have first of all picked my what? Data. I know my x, I know my what? My y. Okay, now the next thing you need to do, I should be able to now break my data into 2 parts, what they call train and tests. Train and tests. So you must be able to split your full data set. So these are our full data sets. We are going to break it into 2 parts, what they call what? The train set and the what? Test set. So what does that simply mean? Train, it means that I want to give this algorithm a certain part of the data. I'm not going to use the full data. I'm going to give it a part of the data, which is called train. So say, go and learn about this data, understand this data. Based on that data, try and predict, then keep that result. Then your test set is another set of data. You are not going to show the algorithm that set. Okay? So based on what it has learned, now give it a new data set that already exists. Now let us see to what extent can you now what? Explain it or predict it correctly. Okay? If the accuracy of that your model is high, then it means that model, we can rely on that model going forward. Okay? So it means that if I bring a new data set based on its accuracy, it's more likely to what? Predict it what? Correctly. But more technically, you have to be careful because sometimes we have what they call the confusion matrix, okay, to now actually evaluate it. So actually based on that confusion matrix, you can now know, okay, how accurate your model is going to what? Be, okay? So what we have done here simply was just to select our data. So let us see how this will work. Because we have created our data into 2 parts, our y and our x. So can you see our data set? This is our y. Our y is just our target variable, which is just our employee turnover. And our x is all those what? Features we are trying to use to what? Explain. Okay, so that's what we have done here. If you are using Python, you may not be able to see all this data at the back end. So it is this data we are now going to break into 2 parts. Our train and our what? Test. But for you to do this, you must first of all bring in some algorithms to help you do that. Okay, you need to bring in this thing to help you do that. So let's go back. So we have broken them into train and test. So I need to now bring in my train and test. So I need to split the data into 2 parts. Okay, so to do that, we have a function. So say from sklearn. So most of your machine learning model, you are going to use this package sklearn. Okay, so you need your model selection. Which model selection? Import my train, test, split. So I want to train the data, test, and split. Okay, but for me to do this, I need to break it into 2 parts. My x, I'll break it into train, test. My y, I'm going to break it into train and test. Okay, and to do that, I'll have my train, x train, X what? Tests, comma. I will have my Y train and I'll have my Y tests. So I'm going to bring it train, test, splits. Now I have to run on my train and my X and my Y. Then what is the test size? So most time when you are breaking your data into two parts, you have what they call the test size. Okay, you can break it into 30%, 70% train, 30% test, or 80% train, 20% test. So it all depends. So I can use 0.3, which means that I am training 70% of the data. That means my model is going to understand 70% of the data, while 30% of the data is not going to see it. Okay, so that's what we have done here. We have broken into two parts. So 70% of the data is going to train with it. The other 30% is not going to see it. So that's what we are going to do here. So if I run this, let me just, so I have to break it one by one. So if I have an error, I will know where the problem is coming from. Otherwise, you can run your whole data once. Okay, you can run the whole data. So you see what it has done? It has broken the data into different parts. My X train, X test, Y train, Y test. You see, I'm still breaking it into different columns. Okay. So now I know that this has worked. Then the next thing I want to do is that I have to apply an algorithm. Okay. Now all the algorithms that you have, it all depends on what you want to do. So you can use a logistic regression. You can use which other algorithm you can use? You can use random forest, gradient boost. You have different algorithms. So you need to try all the algorithms to see which one predicts what correctly. So you can use your logistic regression, that will be easier, but let me use another one. Let me use gradient boost. I think gradient boost will give a better result. So what I will do, I'll say from the package, isn't it? sklearn, what do I want to bring in? Now, but you see, that's your, you need to understand what package you are trying to bring in, okay? It's sklearn, but what we are doing here, we are trying to bring in what they call the assemble. So assemble. So what you are doing here, import your gradient boost. Import gradient boost, because that's the algorithm we are trying to bring. Gradient boost. And please take note, your Python is extremely case sensitive. So classifier. So I need to be sure. sklearn.assemble, import gradient boost classifier. Okay. So that is what we are trying to bring in, that algorithm, gradient boost. Okay. So next thing we are going to do is to create what an instance that instead of me calling gradient boost every time, gradient boost, I will just summarize it. Instead of me calling gradient boost every time, I'll just call it GB for gradient boost, just short form. Okay. So gradient boost classifier. Anytime I'm looking for gradient, but I just call it what GB. That's all. So what do I want to do? I want to make sure that I train and test my data. So what do? I will fit it in. So gradient boost.fit train and Y train and X train and Y train. Remember, we broke our data into two parts: the train and tests. Okay, now once we have done our train and test, it's expected to do your machine learning. So most time, if your data is quite large, it can take some days to even learn and to train the data. Okay, but here the data is not so large, so that's why it can be straightforward. But normally, if you are trying to do this better in your Jupyter notebook. Okay, before you bring it here. So once you have done that, the next thing you are going to do that. Based on the result you have, I want to be able to predict. So we now have Y predicts. What do I want to predict? Based on your result, can you predict for me, based on the gradient boost, can you predict for me my data, which is my X? Remember your X data, the total data. So let us try and predict it. Okay. But I just don't want to predict 1 and 0, 1 and 0, 1 and 0. So what I want to do, I want it to, so remember here, I have created it as Y as turnover, isn't it? And my X is all these variables here. So that is based on what I'm going to predict. based on these factors. But I don't want you to tell me that whether it's 1 or 0. Also tell me what's the probability of that person leaving. So I'll use Y predict proba. Hello. Okay. So you have to also get the probability of it being, you also have to get the probability of it. So you're not just saying he's leaving or not, but what's the probability of him leaving? Okay. And remember that the higher the probability of him leaving, the higher the probability, the more likely is to leave, isn't it? Then with that, you can easily identify. But now I want to pick it on the column. So that's why I'm using all the rows, and give me just by the first column. So that is just row by column. Okay. So that way, most time when you are doing this, you need to understand the matrix. So in your normal Excel, you read it as tables. But in machine learning, we look at it as a matrix and we read it row by column. Okay. So once you have done that, then next we need to put it back in our table, which is our data set, which is our predictions. So we want to create a new column called predictions in that our table. Okay. So what do I want to call it? Y-pred. Then in our data set, let's call it probabilities. After this thing, we should be done. So let's hope that the enemies will not be at work. So what do we call it? Is it Y proba? Okay, Y probabilities. Okay. Predicts that. Okay, so Y pred. Okay, I didn't call it so Y. So let me call this Y proba, so that it won't give us any issues. So Y pred. So this first line is just to tell me to predict it. Then the next one is just telling me create the probability of it. Create the probability. So that's what I am calling this. Put it in this table, and this put in this table. So let us pray that it doesn't give us any issues. So once it has done this, so I have to trace where the error is coming from. Except import gradient boost. Okay. So that's why most times it's advisable run it on your Jupyter notebook first. So once you have run it on your Jupyter notebook, then you can now know where the problem is coming from. So let's see, okay, so gradient. So I made a mistake in the spelling. Gradient boost. So let me see. There's error coming from sklearn.ensemble import gradient, because Python is extremely case sensitive. So the moment you make a mistake and put in a little capital letter S or small letter S, it will just throw off an error for you. So let me check where this issue is coming from. So cannot import gradient boost. Okay, cannot import gradient boost. So let me see. So it should be from my imports. Okay, so in gradient boost, I need to be sure about my spellings. So gradient.
I think it's gradient
boosting. Gradient boosting. Yes, gradient boosting. So gradient boosting. Yeah, I think it's gradient boosting. That's where the problem is. So let's run that and see. So let's see again. So Y predict proba. So that's where the error is coming from. So in my typo, Y predicts. So this is why it's actually much more difficult when you are running it directly here. Okay, so most time the best place, just run it in your Jupyter notebook. then bring it here. So here, what is saying you cannot find. Y predict proba, where is that? Oh, okay. Y predict proba. So at that point, let's see. Y predict proba. So here, gradient boost dots predict proba. I think that should be it. Okay, I hope so. So let's run that. Okay, finally. So now it has run. So how do you know that this what you have done makes sense? Okay, how do you know it has made sense? So once it has created this for you, you go back to your data. So just click on your data sets. Click on your data. But normally, if you're doing your Python, you'd have done all your you have done your what they call your confusion matrix, your accuracy to check how accurate the data is. Okay, so it is based on the final data that you now have to what pick. So can you see it here? It has created predictions and what probabilities for you. Okay, so at this point here, the data will not make sense to you. So let's go quickly to Power BI. So maybe that will make more sense to you. But what it has done for us is that it has predicted. So let me see if I can move it to the beginning. So remember this attrition that we created here. So attrition means yes, he left, okay? He predicted no, he didn't leave. No means the employee did not leave. He predicted no, he did not leave. Actually, he left. Yes, he predicted he actually left. So do you see that? And this is the corresponding probability. So what is the probability of him leaving? So let's put it in Power BI so that we can do a visual to understand what we are trying to explain here. Okay, so let me close and apply. Close and apply. Close and apply. So is my Power BI up now?
No.
No, it's not.
Is it up now?
Yes.
It's up now.
Okay, it's up now. Okay. So remember what we try to do here with our key influencer, okay? But you see, to do that kind of prediction, you can't just do it with your normal word, Power Word BI, okay? So here, let's bring in, okay, this is attrition. This is our attrition, okay? So let me just bring that. So this was the original data, right? This is the original data count. Or maybe should I put it in a, okay, let me do this. Maybe to make more sense this way. Label span, okay. So out of the total, so we have 237 that left, okay. So let us see our predictions. Where's our predictions? So these are our predictions. So these are our predictions. So let me put that there. Don't summarize. So you see that 1 or 0 means, so anywhere I see 1, it means he predicted that he left. The employee has left, isn't it? So that's what we are doing. So I'll put that there, then count. Okay. So let us also put another card there so that you can just see what's happening. What is it? Why is it bringing 2 out for me? Okay, yes, let me put the label on. So what you are seeing here is that this is what it has predicted. So out of these 237 that actually left, he predicted that 122 of them will leave. Okay, if you feel that your model is not accurate enough, you can still go back and still do some fine-tuning. Okay, but because time is already up, so let me just show you how. So assuming you know your, so let's just create a table so that you just understand the concept of what's happening here. So if you are looking at employees, I would have want to know, okay, let's say my employee numbers. Okay, don't Don't summarize. So these are the employee numbers or employee ID. Okay, let's say these are your employee ID. Okay, so let's look at their departments. From which department are they leaving? So these are their various departments. Okay, did they leave? That is attrition. Yes, no, yes, no, yes, no. So yes is that they left. Okay, what did we predict? So what did we predict? This is that they will leave, they will not leave. Then let's see what's their probability of them leaving. So this is their what probabilities. But for this case, I'm just interested in those that who left. Okay, so let me just predict only. So let me have only those that left. Okay, that I predicted that left. So greater than 0. So anything greater than 0 is 1. Okay, so these are prediction for everybody that left. So remember, it's 122 that I predicted. Okay, so let us see what has happened. So this guy, he predicted that he left. He actually left, and he also predicted he left. He predicted that he's 64% chance that he's going to leave. So let's rank them by probabilities. Okay, so he left, and this is 90%. He predicted correctly that there's 90% chance he's going to leave, and he actually left. Okay, but if we do it the other way around, let's look at it the other way around, which means that they have not left, okay, but they are still in the organization, but they are likely to leave. Okay, they are likely to leave. So if so this is no, they have not yet left, isn't it? But you predicted they are going to leave. So for example, like this guy, so if you look whatever his number is, you can actually trace that there's 91% chance that this guy is likely to leave. So if you are sure about this, your model, then this accuracy can also be relied upon. Okay, so this is how you can integrate your Python in your Power BI. Then you can now use this to build your dashboards. All right, thank you very much. So I think that if you have any quick question, we can take.
Wow. This is a lot of.
This is quite.
It's mind blowing.
Yeah, but this is how to integrate your Python in Power BI.
So any questions?
Any questions? Yeah.
Thank you very much. Really appreciate this exposition.
Yeah.
Yes. However, for somebody like me, I use more of R. Like I'm an intermediate user of R. And like you said earlier, we are still going to have to do like an R version of this. But however, before it comes up, I would also do more research and I'll do more of my learning as to how I can replicate this using the R, using the same approach that you've done for us like this.
Yes.
So but with this, it's really an eye opener. And
yeah, but so exactly what you have. If you know how to do this in R normally, remember how we started? We started going to connect it in our Power BI. That means you need to connect your R in your Python, in your Power BI. You need to tell it where your R is. So that's that connection you must do first before you can link it to. Just exactly what we did in Python. The same thing. Just copy, paste, and it will run.
Yeah, thank you very much.
Yeah, that's fine. Yeah, any other question?
Okay, so
I think Damilola is raising his hand.
Yeah, it's true. Someone's hand seems up. Please ask your question. Ask directly.
Yeah, good evening.
Yeah.
Good evening, sir.
Yeah, good evening.
Okay, so thank you for the very educating section, sir. Before now, I never knew Power BI could do machine learning. Really, I have not seen it to that end. So, can we say the advantage of the integration of Python with Power BI presents a better option for visualization of our data?
Definitely.
Because I think all this correlation and regression can be done on Jupyter without the Power BI integration. So what are the advantages we can say the integration of the Power BI and Python is bringing to the table.
So remember that if you understand the whole pipeline, okay, it starts from extraction of your data, cleaning your data, analyzing the data, visualizing the data, right? So in the analysis aspect of it, if it's just basic analysis you are doing, for example, remember we have different aspects of analytics. You have your descriptive analytics, what has happened, which Power BI can easily do for you, why it has happened. So those your drill downs you are doing, Power BI can do that. But in terms of predictive analytics, to some extent, Power BI can do that for you, okay? But if you want to go advanced, like implementing the machine learning, there's no way Power BI can do that for you. So when you also do your basic simulations, that based on these predictions that we have done, you can now create some scenarios, okay? And that is where the power of Python now comes in. Your Power BI alone cannot just do that. So it's now giving you like an extra tool to make your analytics be more elegant. Okay, because again, remember that Python is also very flexible. So as long as you can think about it, you can also execute it. Okay. So that's why you see recently that why Python is actually going everywhere, and actually you can integrate it in almost anything, whether it's in your Excel, anywhere you can think of. Even your database, you can be running your SQL queries right inside your Python. So it's just about how do you use the different tools, okay? How do you integrate them to give you more elegant analytics? I don't know if that helps.
Yes, it does.
Okay. All right.
So thank you once again. And
hello, good evening. Sorry, thank you for the session, sir. But very quickly, sir, if I had installed my Python using the Anaconda module, so I've been trying to like navigate to the part where I'll need to point the do the settings directly to the Jupyter notebook. So I've been finding it difficult.
Oh, it's right on your set. So once you click on your option settings, right? So you see Python scripting.
Yes.
So from there, you have to now switch it to where Python is, not necessarily your Anaconda, but where your Python is. It will automatically detect it for you. There are two. You see Anaconda, you see Python. So you switch it to where Python is.
Okay. What I'm trying to say is that I did not install the Python alone.
No, then there's no way
it came alongside with the Anaconda.
Okay, you didn't install it. It came along with it. And I think in that case, then you can leave it on Anaconda, but try it. But normally, you have to have installed Python first before doing this.
Oh, okay.
Yeah, you have to install Python first and tell it where Python is.
Okay.
Yeah.
Okay. Thank you very much, sir.
All right. Thank you very much. Any other questions?
How can we reach you outside the class?
Outside the class. So I think Michael will share my slides. So on my slides, you have my contact, my email, my WhatsApp, and you can also add me on LinkedIn. So Michael will have my slides. He can share that with you guys and have my contact there.
Okay, thank you.
Good evening, Dr. Francis. I tried to add you on WhatsApp.
Oh, on WhatsApp?
Yeah. No, sorry, on LinkedIn, I meant.
Oh, on LinkedIn.
Yeah.
I think I have the full profile there. So if you just click on it or copy it, it will take you directly there.
But what happened is that I couldn't add you. I've tried to add you before now.
Oh.
I think because you have like a lock on your account.
No, I don't have any. I don't think I have any lock on my account. But anyway, what you can do, you can send me a mail or on WhatsApp. That's fine. You can always add me.
Okay then. All right. Thank you, and thanks for the session. It was actually very, very, very interesting and impacting.
All right. Thank you very much.
Yeah.
Any other questions?
One more question.
Okay. Yes, please.
Okay, for me, I think the analytics space is now cutting across several industries right now, and I think one of the edge we would have as analysts is to have like a domain knowledge of whatsoever industry you are doing. But for now, I've seen that most of the time when you get a job, when you get like a job invites, or when you see job descriptions, you see you now see analytical going into marketing, sales, hospitality, and all. And most times, as analysts, we're not really domain experts. So now, I've had that issue whereby I now start to look at it that, okay, how do I have an edge aside from being a domain expert in this kind of job? Because most times, like now, I'm not an HR person, and I would want to do analysis on an HR, let's say HR related issue. So how do we navigate that part? Yes, because it's really been bothering me.
All right. If you recall the first one of the slides I put where you look at the data science, okay, that there are three aspects of it. Okay, you have the domain knowledge, right? The domain knowledge. Now remember that as a data analyst, you just work with numbers. You know how to analyze the numbers, but you don't know what is happening there, right? But the thing is that for that problem to come is that somebody will have come in and tell you, this is the problem we are having. You listen to the problem, okay? That is where you need to understand that as statisticians, then in the past, you can analyze data in any way. It doesn't mean you have to be in that particular field, but based on the data, you can start understanding, oh, what this is measuring, why is it measuring, how is it measuring it? Because at the end of the day, you need to interpret it. But for you to interpret that your result, the problem must make sense for you to validate whether this result is answering the question. So it means that the moment you identify, oh, they are telling you that HR, they are having a problem that employees are leaving. The question is that why are they leaving? So it is your job now, because as part of the link, you must do your own research. Okay, so as you get different data sets, that's why I mostly recommend, like if you go to Kaggle, if you are learning your Python, if you go to Kaggle, your Zindi, you see data sets from different domains. That gives you opportunity to actually understand the different work domains. So take time, first of all, to understand what is the problem. Go back and try and understand, okay, this is HR. So let me understand, what is the role of HR? What are their responsibilities? Okay. Why is this problem likely coming? Why is this problem likely happening? Okay. So with your understanding of that data, you start going into different domains normally you would have never gone into. And that's one thing that as data analyst, it makes you become like a consultant, which means that you have solution to everybody's problem. Because the moment they say, I have this problem, even if you don't know it, you say, I know it. Why? Because you are going to research to understand where their problem is coming from. Then they are now talking. Then you now know specific questions to start asking. Then that's how you can start building your knowledge in different domains. I'm an accountant. So I'm an accountant. So the question is that, what is an accountant's role? And how do I bring in Python or machine learning in all these things? So I need to first of all understand what is the role of an accountant first. Okay, all those is process of how does he collect the data, classify the data, how can I automate it? So it's because you understand the role and the processes, then you now know what I'm going to apply or how I'm going to analyze it. So that's how you get even somebody who reads Edo language, there's a role for you here. If you read Edo language, there's a role for you here, because now we talk about natural language processing, NLP. Your Hey Siri, okay, it's in English. You can also do your own in Yoruba. So there is a role for you. So irrespective of your domain, there's a role for you in the data science space. All right. I don't know if that helps.
Okay. So, well, I think we will still have you again. So, I don't know. are people having, because I'm seeing people say like, oh, this is awesome. Is there another aspect? I know you and Mr. Shea have discussed maybe like having hard version. I don't know if you want to do that one again.
Okay. So, subsequently, I can do the arrow version, but it all depends too.
Okay. Anything you want to do, we are home for you. You are part of the house anyway. Just let me know when you want.
Yeah, when I'll be available. Okay, that's fine. That's fine. Okay. Any other questions?
Okay. There's a question we normally ask. So
okay.
I don't know if you have. Okay, someone's hand is up. All right. Damilola, your hand is up.
So you mentioned a link where we can get data or.
Oh, okay. Zindi. You have cargo. You have Zindi. You have cargo. You have Zindi.
I'll type it in the chat box.
You can type in the chat box. You have cargo. You have Zindi. Cargo is worldwide. You have data sets from and competitions from all over the globe. Okay. Zindi is more African.
Can you spell the Zindi? So I don't think
Zindi, Z-I-N-D-I. Zindi. Z-I-N-D-I. Zindi. Okay. So if you search it on Zindi, I think Zindi.com also. If you search it on your Google, that should come up.
Okay.
Yeah, Zindi, yeah. Zindi, yeah.
Okay, so to wrap up, we want to ask you what advice you have for people just starting out. A lot of people are really inspired by what we shared.
Okay.
Yeah, advice on how they can navigate this ever-expanding.
So most times, you see, especially when it comes to all this programming and all, I've never liked programming. Okay? But what I started understanding is that when you go through all this cargo and the rest, they will tell you that all those codes they write, they don't know all of them. So sometimes what is even discouraging is that, do I need to cram all those codes? Because that's the question I normally ask first. How do people know all these codes? Okay? It's really not about the code. Just understand that your Python or your R is just a tool for a solution. It's not about the code itself. It's about providing solution with it. So even if you don't understand remember this code, but can you interpret what the code is saying? So that's the first thing I realized, that even when they do their presentation, they still say that they don't know all the codes. And that is why, especially in times like now, we are even lucky. In the past, those who actually learned coding learned it the native way. But now everything is online, free. The problem you have is that it's too much information. That's the problem now, okay? And there's one place that you need to go to, which is called Stack Overflow, okay? So we may have different languages. We are divided by different programming languages, but we are united by Stack Overflow. So the moment you're having an error, just copy that error, go and dump it on Google, on Stack Overflow. You will see a solution from it. So the more errors you have from your code, the better for you. That's how you actually learn. So I'm sure that is the first thing that people get discouraged, and that's how I first started. Like, how will I start all this coding? Now, it didn't make sense at first to me. When it made sense to me was when I first of all understood the whole pipeline about what I want to achieve. It all starts from extracting the data. So how do I get that data? That's the question. Most time it may be in Excel, but you see, for most organizations, it may not be in Excel, it may be in a database. That is how they bring it into export it to you as a CSV that you now clean up and start. So the first thing that I started learning, how I started going into coding, was to first of all understand, how do I extract this data? And the first place to extract your data is to learn SQL. Is to learn what? SQL. Because SQL is actually a very simple language, just like English language. The moment you understand how those syntax work, it now opened my eye. Okay, this is what coding actually is. Even your Excel, even those your if function, VLOOKUP, actually you are still coding there. But it's for you to have an idea of, okay, I understand how this syntax is working. That is the same way you should look at SQL. So the moment I understood how SQL works, and I say, So that is how I now get my data. So it means that while I'm in Power BI, I can also query direct to my database. So I would learn SQL to learn to query my database. So when I get my data straight from SQL, remember the next pipeline, so now I clean the data. So how do I clean the data? I have to clean it in my Power Query. Clean, transform, and do the rest, okay? But you see, to clean it in Power Query, remember that the language at the back end is your M. But you may not learn all the whole M language, okay? So they have already made life easy for you. But if you want to also clean and transform, then your Python or R can also come in. So that is how you now learn how to analyze. Then the next is to what? Visualize. So it's about extraction, extract the data, clean and analyze the data, and what? Visualize what? The data. If you want to take it a step further, you now have to do deployment. So the first thing I started learning was understand SQL. From SQL, I put it to Power Query, clean the data, visualize it. The next thing I want to do, what if I want to start doing my predictions beyond normal visualization? Then I need to start going back to what? Predictive analytics. So that's where your Python now comes in. So when you are learning your Python or your coding, understand the objective of why you are learning it. And because Python is a programming language, please take note that you see somebody in a data science is typing all the Python script, doesn't ensure that necessarily mean that he knows how to use Python. You can see somebody who writes softwares with Python, doesn't mean he's a data scientist. He can do what you are doing in data science, okay? So you just choose your path. Because it's so broad, I now know, okay, I don't want to bother myself with learning everything. I want to go the route of data science. So pick your path. So it is for data science I'm going into. But for it to make more sense to you, use data that you can really relate to. That's why your domain knowledge comes in. So if you are in HR, use HR data because you are used to HR. So everything in the data set you are looking for, you can easily relate to it. Imagine somebody who is an accountant is trying to understand HR or is trying to understand sales. It may not make sense to him. So pick data that you can use in your own domain or knowledge, in your own domain. So that is how gradually you start being exposed to all these things. Okay, so that's just the whole pipeline. So from extraction, analysis, visualization. So if I look at it from that space, that means the tools I need to learn: SQL. For the analysis, I need to learn Excel, Python or R. Then for my visualization, Power BI or Tableau. You may have others, but these are the basic way to just look at it.
Thank you. So someone has, maybe I'll just bundle the questions together.
All right, that's yeah.
So let's say just 3 now. So Madam J is asking, how long will it take for a beginner to learn Python? And she's also at the same time asking, are you advising that we learn SQL before Python?
Okay. How long will it take you? I will still tell you I'm a beginner. Okay. But the problem is that start. You need to start. Okay. You need to start. Now, why I use that SQL? Because if you look at Python in itself, you would think it's actually very difficult to learn. If you really want to learn Python, basic Python, it will not take you more than 2 days to actually learn it. Basic, 2 days. But what you can do with it will take you a lifetime. Okay, so that's why I say even at my own level, I will still say I'm a beginner. But the thing is start. But for your eyes to be opened on how coding works, start with SQL. Okay, start with what? SQL. Basic SQL, as long as you understand how to select the data, bring out the data, select certain data, it will not take you more than a day. A day is okay for you. But it is the practice that will now open you to different possibilities, even with your SQL. Okay, so start with SQL. For me, I started with SQL because it's with SQL that opened my eyes that in all these other things started making sense. Normally, actually, if you are used to Excel, when you are learning your SQL, look at SQL from the point of Excel. Because remember, Excel in itself, some people use Excel as a database, but remember that Excel has its own limitation when the data become very large. Okay, so that's why instead of you keeping it in Excel, it's better to use a database. That's why you have your Access or your Microsoft SQL Server. Okay, but the language they use to relate to that database is your SQL. Okay, so that's why you start with what? Your SQL. But when you are learning SQL, look at SQL from the point of Excel. Okay, so that's what I would advise. If you are starting it, yes, start with SQL. But when you are learning your SQL, look at it from the point of Excel. Then from there, progress towards Python or R, depending on what you prefer. I don't know if that helps.
So thank you. So the last part, I said those are two. The third and final question to wrap it all up is, I don't know if you can compress, but we want to hear your whole journey. How did you start into this space? I know, well, you've mentioned that you over 10 years in this line, but then it all had a starting and an interest point. Where did it all start?
Okay, so let me say, first of all, I'm a very slow learner. So anything numbers, I'm not the person for it, because these numbers don't make any sense. Formulas don't make any sense to me. So I've always been a slow learner in school. Okay? But the thing is that every time you start, you need to analyze your data. Because in school then, you have to do your projects and the rest. And me, I was learning accounting. So they say you have to go and meet EcoStat for them to run your analysis and the rest. So I was like in 300 then, when I was doing accounting, we're doing research methodology. So they asked us, you have to go and meet those in EcoStat to run your analysis. So when I had gone to look out for them, so the amount they were charging, I was like, this is already business. So why not let me go and learn how to do this and start making business? So I started it from a business point, not that because I was so smart. I looked at it as a business opportunity in school. Okay, so I met somebody, one of our lecturers, if he can teach me how to run all this regression. He told me that when I should go and learn, when I should come and teach him. So that's how and this was about maybe 2004 or 5. So as at then, we didn't have internet, we didn't have all the resources like this. So it's just basic library that we're doing. So what I decided to do is to go back to read statistics. So the foundation is all in statistics. So I started going back to statistics to actually understand statistics. So that's how I started my journey in it. Then I now learned one software, Easy Regression. So that was the first software I learned how to run regression, Easy Regression. And remember, I was in accounting. I had no reason to be doing anything statistics. Maybe we have done it as a course. But when I had run it, I just compared with what other people were doing and said, this is the same thing, no? So I started it as a business then in school. So I started doing analysis for everybody. So with that, the same way you're talking about domain knowledge. So somebody in medicine will bring his data for me to analyze. So I will even analyze a data, not in my field. But with that, I can be exposed to different domain knowledge, different domains. Okay, so that's how actually I started. Then in my as at final year, I was already doing analysis for those in PhD. So I've also helped people while I was an undergraduate to graduate in PhD. So which means I now realize there is a gap. That it's not about saying you have PhD. We don't have skill. It's about skill, not certificates. Then it now made sense to me. Then I had to go back to write JAMB again, to go and read economics and statistics. So when I graduated accounting, I went back to read economics and statistics. So I was like a mechanic. You know how we have mechanics and you have engineers? The mechanics know the work, but they don't know anything theory about it. The engineers can tell you all the theory about it, but don't know any practical about it. So that's how I went back to read economics and statistics, to understand the practice and understand the theory. So the heart of everything we see today starts with statistics that moved to econometrics, to data mining, and now they're calling it machine learning. But it all starts in statistics. So that's how it all started. So at final year, Then I now saw Excel for the first time. Not that I was not exposed to Excel. I was using Excel, but not as deep as. So I saw somebody use. So it was statistics, but he was doing decision tree in statistics. I was like, wow. I thought I knew Excel, but this is a whole different level. So that's how I went into Excel on its own. Then started going deep into Excel. Then running regression in Excel. So everything you do in your Python, you can actually do it in Excel. Okay, so that's how I just started growing and growing. But the challenge I was having is that because I was in academy, what I noticed that what I was doing is data analysis. But you see other people say they are doing data analysis, but we're not doing the same thing. I will be using softwares like eViews, Stata, SPSS, okay, to do different things. But they may just use Excel and they say they are doing data analysis, but we are not doing the same thing. You are not doing regression, you are only doing visual, and you say it's data analysis. It did not make sense to me. Until later, I started coming for different trainings. I was like, this Excel on its own. They used to do visuals. Then it made sense to me that what we do in academic is just basically we write research, put it in a journal that nobody will ever see. And yet we are recommending for firms. But firms, companies are now using internal data to run it, do their visual and dashboard and make decisions immediately. So there's a disconnect between that, what they do in the academia and what they do in the industry. Then it made sense to me that the kind of data that we use is what differentiates and the kind of analytics tool we use. But we are saying the same thing. But where I can now see the bridge between what we do in the academia and what they do in the industry is your visualization. Rather than you go to bury all those your results in journal that nobody will ever see, recommend to governments that will never understand what you are saying, then with your visuals and presentation, then it made more sense that is what bridges your findings with what managers can understand. So all the tools, so that's how I started gradually moving to SQL, to Python, to R, and all the rest. So when I hear a tool, I say, this tool is good, but how can I integrate what I already know? So it's not just about understanding all the tools, but understand how to integrate all together to make sense out of it and make you work very smart. So that's how I just grew over to, because even when I did my PhD some years ago, but what I was doing then was still prediction, but I was using eViews. So what I have done with Python, I had done it with eViews. Okay, so it was just about the tool, but the domain knowledge is there. That's why I say the foundation for you to get into this is statistics. You can't run from it. You need to go back to statistics. Okay, so the statistics that actually opened my eyes to everything that I know today. Yeah.
Journey is a very robust.
It's a very long, and I'm still in the journey because I'm always a student. So if I see training anywhere, I will still attend it.
I was always thinking it's just accounting until now that you said you even went back to do econometrics and statistics. Wow. Wow. What's now like for next step for you? Maybe some of us can latch onto it. What's like your road plan for this year? What's the next step?
So what I've been doing so far, so since I've been teaching accounting since, and most times for those who are for those who are accountants, and they start panicking, future of work. That means that robots are coming to take over our job. Okay, I was not like, okay, it's not going to take over your job as long as you know your role very well. But the truth is that with technology now, everything is automated. Everything is automated. So for example, for accountants, there's a firm in the US, they are called bookkeepers. So all your bookkeeping process from collecting your source documents to extraction classification to presenting trial balance, everything is automated. No human interference. Which means that if we needed 10 accountants, with that kind of technology, you now need just one. So question now is that as an accountant, what do you now have to do? It means you may be unemployed. But for you to say you're unemployed, it means not that you're unemployed, but your skill is no longer relevant. So you now need to upskill. So because of that gap, so I'm launching an academy called Accounting Analytics Academy. So which will help accountants and those in finance. How do I bring all these tools to now start understanding the back end of those programs that you are running? So that's that's the plan for. I think we should be launching by end of this month.
Accounting
Analytics
Academy.
Accounting Analytic Academy, yeah.
Okay. Are there any things you want to share with the audience, like where they can? Okay, your slides. That's where they are.
This slide you have on my contact, but once we have developed everything, then I can also come and share and launch. So we'll be doing the training for mostly accountants and those in finance. But much later, I think I will still go into maybe HR, sales, and the rest. But for now, just let me be biased towards accounting, so I don't leave my people, so they don't say I've left my people. Yeah.
Okay. So thank you once again, and thanks to everybody for staying this long. It's been a pleasure, and thanks a lot for this amazing knowledge here, both on the technical side and also on this inspirational side. We greatly appreciate you. We know we will have you again, so but then we never take for granted, your availability and the willingness with which you share what you know. So thank you, and everybody. Happy New Year.
All right, thank you guys. Happy New Year.
Bye. Thanks for joining. Thanks again, Dr. Francis. Thanks to everybody. Bye.